Hey guys, and welcome to this lesson. So we're going to see how you can convert a decimal number to a binary number. So I'm going to demonstrate you step by step in depth so you guys can have a solid understanding how to convert any decimal number to a binary version of it. So let's look at the first main thing that you need to remember when you're converting any decimal number to a binary number. So the first and probably the most important step is to put down this row of values. As you can see, there are 8 numbers and you have to remember these 8 numbers. So in order to remember these values, start with the number 1, go from right to left and double that number 7 times. For example, start with 1 on the right side. So for your next number, double the 1. So 1 into 2 is equals to 2. So 2 is your next number, remembering to go from right to left. For your third number, double the 2. So 2 times 2 is equals to 4. To continue the sequence, double the 4. So 4 times 2 is equals to 8. Repeat this process until you double your original number 7 times. So let's take a look at the concept now. So the key to remember this conversion is that every single one of the values we put in that row are going to have either number 1 or number 0 assigned to it. To convert the IP address, we will take that string of numbers and start from left to right this time. So while writing the number row values, you're going to start from right to left, but during the conversion, you're going to start from left to right. For each value, we can ask this question: can I subtract this value from the decimal remaining? If the answer is no, then you put a 0 under the binary value, and if the answer is yes, then you put 1 there. So now we're going to do a step-by-step example. So we will take the IP address 154.31.16.13 and start with the first part, which is 154. So we will take each octet and separately convert its decimal number to a binary form. So the first step is that you ask a question: can I subtract 128 from 154? So the rule of doing is that you just take your number, which is 154, and keep on asking questions like this, that can you subtract that number from the row of the values one by one. So first we ask that can I subtract 128 for 154? So the answer is yes. So we assign 1 to 128. As you can see, we have written 1 under 128. For step 2, we will see and ask that can I subtract 64 from 26? The answer is no. So we assign 0 to 64. The third step would be that we will ask the question again: can I subtract 32 from 26? The answer would be no. So we assign a 0 to 32. For question 4, we will say, can I subtract 16 from 26? The answer is yes. So we assign 1 to 16. That will give us a remainder of 10, as 26 minus 16 is equals to 10. So next you should ask, can I subtract 8 from 10? The answer is yes. So we assign 1 to 8. Further, for step 6, we will have a remainder of 2, as 10 minus 8 is equal to 2. So you're going to ask the question, can I subtract 4 from 2? Answer is no. So we assign 0 to 4. Just remember this too, that you will always take the remainder of the values. So step 7 is, you'll ask the question, can I subtract 2 from 2? Answer is yes. So we assign 1 to 0. And we will have a remainder of 0 left. So the rest of the values in a row, we can assign 0. So now we know that the decimal number 154 is 100111010 converted to binary form. And to double check, we take the values assigned with 1 and add them together. So 128 plus 16 plus 8 plus 2 is equals to 154. So in our IP address, the next number of the second octet is 31. So let's do all those steps for 31 now. So you're going to first ask, can I subtract 128 from 31? The answer is no. So you will write 0. Step 2, can I subtract 64 from 31? The answer is no. So you will write 0. Step 3, can I subtract 32 from 31? The answer is no. So you will write 0. Step 4, can I subtract 16 from 31? The answer is yes. So you're going to write 1. So now you'll ask, can I subtract 8 from 15? Remember, it's the remainder. So the answer is yes, and you're going to write 1 under 8. Further, in step 6, you will ask, can I subtract 4 from 7? The answer is yes, so you're going to write 1. Step 7, can I subtract 2 from 3? The answer is yes, so you'll write 1. And step 8, which is the last step, you can ask, can I subtract 1 from 1? The answer is yes, so you will write 1 under 1. So the decimal number 31 is 000111111 converted to its binary form. And to double check, 16 plus 8 plus 4 plus 2 plus 1 is equal to 31. So our third octet number is 16. But this time we will perform the conversion in one step now. So you can see what we've done is the number is 16. We started from 128, remember, left to right. So can you subtract 128 from 16? No. Can you subtract 64 from 16? No. Can you subtract 32 from 16? No. Can you subtract 16 from 16? The answer is yes. So you will write 1 under 16. And we have no remainder left, so the rest values will be 0. So the decimal number of 16 is 000100000 converted to its binary form. And the last octet number is 13. So you're going to do the same steps again. Start from left to right, and you'll see that we only get 1s under 8, 4 and 1. So the decimal number 13 is 0001101 in its binary form, and to double check you will again do 8 plus 4 plus 1, which is equals to 13. So now finally the IP address 154.31.16.13 has its binary form equivalent of 1001111.0001000.0000101. So guys, this was the end of our lesson on the conversion of decimal to binary. And if you want to do the conversion of binary to decimal, you just do the vice versa of this. So I hope you guys got a good understanding of how we can do the conversion. Hope you guys could easily understand my example and were able to understand how you can actually convert a decimal number to its binary version. And now I'll see you guys in my next lesson. Hey guys, and welcome to this lesson on conversion from a binary number to a decimal number. So the fundamental learning of this concept is that the first and probably most important step is to put down this row of values, which is 1, 2, 4, 8, 16, 32, 64 and 128. So in order to remember these values, start with the number 1, go from right to left and double that number 7 times. So 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32, 32 times 2 is 64, and 64 times 2 is 128. So this is an easy way to remember it. And the key to remember is to place the number row values under the binary numbers from right to left. So let's take a look at an example. We will take the binary number, for example, 1001111. So I have written it in bold over here, and under that we have written the number row values, as you can see, from right to left. So 1, 2, 4, 8, 16, 32, 64, 128 is exactly under the binary number. So the second step is that you put a line below the number row of values and only put the number row of values under the binary number which has 1. So wherever there is 1, you will only write it again at the bottom. So as you can see, under the 0 values there is nothing, but under the 1 values I have written the same value of that from the number row value. And the next step you do is you add those number 1 values. So as you can see, I've just added a plus mark after 128, 16 and after 8 to 1. So you're going to add them. So once we add them, you will get your answer 155. So 155 is the decimal version of this binary conversion. So this conversion is really easy to understand. All you need to do is write the number row values under your binary number. Only write the numbers under 1, add them, and you'll get the total value. And that will be your decimal number of that binary number. And now I'll see you guys in my next lesson.